Okay, good morning everyone, and welcome to GI Energy's webinar on energy resiliency and energy savings. This is the first of two webinars designed for the California marketplace that will address the issue of resiliency of your energy supply. And today we'll focus additionally on financial solutions that may relieve some of the budgetary burden that we imagine so many are facing. Just a few ground rules before we get started. The remarks will last for about 45 minutes, and allowing for some time for questions, we'll be finishing no later than 11 AM Pacific. Lines will be muted throughout the presentation, but please feel free to submit questions using the Q&A box at the bottom of your screen. This session is being recorded and will be available online shortly should you wish to share it with colleagues or recap the information that it contains. Before we actually get started, we'll be taking a quick 3-question survey about today's topic. Using your smartphone, you can go to menti.com and enter the code that I'll give you in a moment. And finally, we'd like to hear your opinions about today's session. So please email us with comments and suggestions about other topics that you'd like to hear about. But first, some introductions. My name is John Passmore. I'm a senior sales consultant for GI Energy, and I'll be your moderator for today's presentation. GI Energy designs and develops distributed energy systems for the institutional market, providing resilient, reliable, clean, and cost-effective energy solutions to clients looking to update and future-proof their energy supply. Offering services from feasibility studies through design and construction to operations and maintenance, GI Energy has an established Californian team with deep experience in the regulatory and incentive programs available to local businesses. And as an affiliate of Shell New Energies, we can provide access to Shell's abundance of competitive programs and solutions. I have two colleagues presenting this morning. First, Jeff Bogg, based in Anaheim, California, leads GI Energy's Service Solutions segment, a business focused on cogeneration assets from development right through to operations and maintenance. He has 20 years of experience in the industry with a proven track record of developing complex, challenging projects, applying an array of skills developed through leadership roles in financial analysis, commercial structuring, and technology at GI Energy and other major companies. You'll also hear from Libby Edgar, who joined GI Energy as Chief Financial Officer from Shell New Energies when Shell purchased a majority and controlling interest in the company in early 2018. She has 20 years of experience in the energy industry, spanning commercial activities and operations, and developing a wealth of financial capabilities, including commodity trading, portfolio development and optimization, mergers and acquisition transactions, and project structuring, financing, and execution. We also have two guest speakers today. John Dewey, the CEO and founder of Mustang Renewable Power Ventures, based in Newport Beach, California, focused on public-private partnerships for environmental infrastructure development with municipal clients. Perhaps of particular interest to today's session, John will talk about the Santa Barbara Resource Recovery Project that includes a material recovery facility and an anaerobic digester as an example of how waste can be converted from or diverted from landfills and be used to power local homes. Mustang's portfolio of assets actually includes 3 properties located on former landfills. And finally, Carlos Pabon, Regional Sales Manager for AB, a company specializing in the design, construction, supply, and maintenance of packaged cogeneration systems. Currently based in San Diego, Carlos has extensive experience in cogeneration markets around the world, covering many applications, including natural gas-fueled industrial and commercial systems and biogas-fueled applications for municipal and industry-based clients. We look forward to their remarks. But before we get started, let's quickly turn to our survey. I'd like to ask you to go to www.menti.com on your smartphone and enter the code 78217. So that's www.menti.com and the code is 78217. Please answer the 3 questions and we'll see the results right away. Those 3 questions are, across the US, how many billion-dollar weather and climate disasters do you think occurred in 2019? So across the USA, how many billion-dollar weather and climate disasters do you think occurred in 2019? Okay, a second question. Is your business or operation dependent on the reliable delivery of electricity? Is your business or operation dependent on the reliable delivery of electricity? But it looks like we're talking to the right audience. And our final question, how would you classify any PSPS events, any public sector power shutdowns you have suffered? How would you classify any PSPS events you have suffered? Severe, moderate, etc. Interesting. A third got away with it. That's very interesting. Well, thank you for completing that. But let's now get to the meat of the presentation. I will now pass you on to Jeff Bogg, who will start our presentation.
Good morning.
Right, let's go on to the next page if we can.
All right. Thank you for that, John. And thank you to the audience who joined us today for what we believe to be a timely discussion concerning energy resiliency. Agreed that looks like we do have the right audience here today for this discussion, so we do hope you find it helpful. Just wanted to kind of quickly talk about the objectives of the webinar today. At the highest level, we want to make sure that you have a solid understanding of the current state of play with California public safety power shutoff events from all the key perspectives, including utilities, policy in Sacramento, but most importantly, at your level, the rate-paying customer, where as a business or finance manager for your organization, you're trying to manage operational costs against a backdrop of business and continuity plans that are becoming increasingly difficult to maintain. So just quickly, we're going to define the scope and risks related to PSPS events. As mentioned, a quick overview and survey of policy and legislation in the state of California, potential solutions that can be enabled to protect against and mitigate the risks and costs presented by PSPS events. We'll discuss some basic business and financial models that could help your organization mitigate these risks. We'll go through the case studies that John Dewey and Carlos Pabon are going to present. And then we'll have a quick discussion at the end just to, how you can start your path for planning energy resiliency with your organization. So I think we know most of the unfortunate headlines to the story. It really began several years ago, but became most prolific in the 2018 wildfire season, which was the deadliest and most destructive ever recorded in California. Over 8,500 acres or 8,500 fires over approximately 2 million acres in the state. And this set up the conditions that we saw last year, which was more of the defensive policy of public safety power shutoffs due to the liabilities and insurance claims that arose from the 2018 fire season. So what we saw last year was pretty astonishing. About $2.5 billion in economic costs from the PSPS events that transpired in October and November. About 2.5 million people were directly impacted due to the PSPS events, certainly in PG&E service territory. And across the state, about 60% of the counties experienced 3 or more PSPS events, which is pretty astonishing, and well publicized outages in Sonoma and Napa where they experienced 4. And these on average lasted about 45 hours. In some cases they were less, a few hours. In other cases more than a week. But the conclusion is that this is a problem that will persist and will last into the future, and ratepayers have been advised to expect 5 to 10 PSPS events per year, lasting anywhere from 2 to 5 days apiece. So what are our policymakers and legislators doing in Sacramento to help address this problem? COVID-19 naturally has kind of slowed the pace of legislation in Sacramento, but there are a few bright spots to report. The current fiscal year budget did preserve $50 million in community energy resiliency funding, which will really be focused on critical and essential facilities that will need to ride through during PSPS events. Most people in the audience are probably familiar with the SGIP program, the Self-Generation Incentive Program. Last year, there was a new equity resiliency bucket of funding, about $513 million, that was created specifically to target tier 2 and 3 high fire threat districts. And these are defined as having 2 or more PSPS events annually. And this was fairly noteworthy because the original budget allocation was $100 million and increased almost 5-fold. And that was really in direct response to the fallout from the 2018 and 2019 fire and PSPS seasons. Last month, Senate Bill 1339 got additional wind behind its sails, and SB 1339 is really set up to do a lot of things, but now there's a more formal framework in play to accelerate the utility interconnection process for customers that want to install and operate their own distributed energy generation. And it appears that they're finally getting serious about tackling tariffs to better accommodate on-site energy resiliency solutions, which tend to penalize on-site generation with standby charges and departing load charges. There's also the utility request for offers for microgrids at select substations, particularly in PG&E. PG&E ended up shelving an RFO that had been released earlier this year. They're kind of taking more of an ad hoc approach at the moment with standby generators at select substations, so not completely clear how that's going to play out into the future. But the takeaway for us today is that while there's an impetus to improve the situation and reduce the the risk and impacts of PSPS events, there really isn't going to be any near-term silver bullet coming from Sacramento or the utilities themselves. So this will be a persistent and long-term problem that we'll all need to ride through in the fall of each year. So let's talk about economics and numbers. So we've kind of described the scope and scale of the PSPS issue, but how will this translate into your utility bill if you're a California customer? So looking at PG&E, which obviously got most of the headlines in the last fire season, PG&E has a history of annual rate increases, and here you can see the percentage change in the two basic components of the bill, energy and demand charges. And the anticipation is that rates are going to increase fairly dramatically. They do have a rate case in front of the California Public Utility Commission, and looking at increases in the distribution and generation components of the bill, 17% and 8% respectively over the next 2 years. So it's also important to note that the last time PG&E came out of bankruptcy, which was in 2001, ratepayers suffered an increase on their bill of an average of around 30%. So we think there's really only one way rates are going to be going, and that's going to be up. So with this problem set and challenges in mind, we step back, and when we talk with customers, we talk about the cost of doing nothing, and the risks of PSPS events are fairly well defined. Now that we've been through the first season, happy to see that a good percentage of our audience today has not had to experience one yet, but it looked like maybe over half had. So, and the problem with these types of events is the risks are known, but the costs of outages aren't calculated until after the event, and you get the bills. So for each organization and business, the cost of doing nothing is going to be a little bit different. But for like a manufacturer, with suffering a 16-hour outage, the average cost to that operation is $350,000 in lost revenue or disposal costs, whatever the case may be. For non-manufacturing, it's about $150,000 based on the Sullivan study from 2015. And there are other disruptions in terms of supply chain, which many industrials and commercial and industrial customers are experiencing now due to COVID-19. It becomes even more acute during PSPS events. Obviously, health and safety, an issue for your employees, for your families, and we're seeing now, after the first PSPS season, insurance rates increasing significantly. Reports of nearly 5-time increase in premiums for high threat fire district locales. And as we talked about in the previous slide, the cost of utilities is going up significantly. Almost $2 billion will be added to utility bills over the next 2 years for PG&E. So then the question becomes, how can we reduce, minimize, and mitigate the risk of PSPS events? And we think the best answer is to take control of your energy supply. Now, we recognize that most of our audience today is not in the energy business per se, but as we saw from the survey question, you depend on reliable and cost-effective energy to sustain your business or operation. So companies like GI Energy and AV Group, we're in the energy business. This is what we do, and we deliver scalable, modular, and resilient solutions that minimize risk to customers, either in an EPC model or energy as a service. But there are companies out there that can help you take control of your energy supply, energy costs, and mitigating risk presented by PSPS events. And we think there's a very strong and proven menu of options, what we call distributed energy resource options, beginning with gas-fired electrical generation, combined heat and power, fuel cells. We think this is a really strong solution for many customers, because natural gas prices are basically at historic lows, as we know, due to shale gas oversupply and reduced demand for gas due to COVID-19. As we see in our electric bills and some of the information presented here, that electric prices continue to go up. So the economics around gas-fired generation are very strong, and the supply of natural gas is not correlated with public safety power shutoff events. It's a very reliable source of energy, and is virtually limitless. A gas-fired generation gives you the ability to ride through outages for hours, days, or even months, which is why we say 365. And of course, with some applications, we can recover the thermal energy and deliver that to the host facility in the form of hot water, steam, chilled water, and these types of applications also are very efficient from an energy delivery standpoint. So they don't require a lot of space, and can deliver reliable energy to meet the demands of the facility. There's also a tremendous amount of interest in renewables and pairing renewables with other technologies at a site to mitigate the risk of PSPS events. Solar probably being the most popular here in California, obviously, due to the very strong solar resource. Solar, obviously 100% renewable, and that helps some companies and organizations align with their carbon reduction goals or renewable energy supply requirements. The problem with solar, of course, is that it depends on the sun, and will not be the sole and exclusive answer for a long duration PSPS event, but coupling it with energy storage and possibly gas-fired generation, it provides valuable optionality and a lower cost form of energy to ride through PSPS events. The flip side with solar is that depending on the requirements of the customer, of course, it can use it does require quite a bit of space on the rooftop, carports, ground mount. There's different options, and depending on how the customer wants to mitigate the risk, the area requirements can be quite high. Solar and battery, when paired together, do offer some benefits, certainly on the interconnect process, going through the net energy metering process, whereas electrical gas generation does not. Goes through what the conventional rule, what we call Rule 21 interconnection process here in the state of California. So there are other advantages to renewables, particularly coupled with energy storage and the availability of the investment tax credit for those technologies. The key with all of this is really just to understand how energy is used at your site, what it costs, and how these technologies, either individually or integrated in combination, can achieve facility level cost savings and resiliency goals. So with that, I'm going to hand over the discussion to John Dewey, to talk about his microgrid project in Santa Barbara County. Really exciting project, and we're absolutely delighted to have John here today. I think you're going to find his discussion very interesting, certainly in terms of some of the business and economic considerations that John had when developing the project. So John, I'll turn it over to you.
Thank you, Jeff. Appreciate that. Start with a little project background. We are a public-private partnership infrastructure developer. We were selected in 2010 by Santa Barbara County and 4 additional cities to develop a waste diversion project at the county-owned landfill. It was a competitive bid process. We were selected as a preferred developer out of 10 proposals that were submitted. Once we were selected, entered into the CEQA environmental impact review process, which was significant, as you might appreciate, in the Central Coast of California. Subsequent to that, contract negotiations. Our client is Santa Barbara County. However, there were 4 additional cities, the cities of Santa Barbara, Goleta, Buellton, and Solvang, that also committed solid waste to our project. Simple goal of the project, the landfill was running out of capacity. That's a county-owned landfill. They wanted to divert the maximum amount of waste away from landfilling. They wanted to achieve regulatory compliance with a number of waste diversion mandates coming out of Sacramento, including a goal to divert 75% of organic waste, food waste, and other compostables from landfilling. They also were interested in having the maximum renewable energy components and, of course, related greenhouse gas reductions. Our project is described as an environmental infrastructure project. It's good for the environment, it's great for the community, and it more than doubles the remaining life of the landfill and diverts organics from landfilling. Of course, organic waste is buried in the landfill, creates methane. You can capture the methane with some of the landfill gas collection networks, but they are not perfect, and a lot of methane seeps out to the atmosphere. In any event, we were selected as a design, build, operate contractor. The county actually was the owner of the project and completed the financing of the project. They issued in November of 2018 about $167 million in tax-exempt muni bonds at less than a 4% cost of capital. We had initially been selected to be the design, build, own, finance, operate contractor. However, our cost of capital with an equity rate of around 15% and a blended cost of capital around 8 or 9% on a project exceeding $100 million, 500 or 600 basis points was significant to the ratepayers when you look at the overall financial costs of the project imposed on their waste system. In any event, we commenced construction 2018, late in the year, December. We're about 85% complete with construction right now. We're due to start commissioning the project in September of this year. We should be fully operational by the end of 2020. We have a long-term operational contract. We also partner with our local waste hauler who operate one of the facilities. Anyway, in terms of project description, there are 2 main facilities we've developed. One is a material recovery facility, or MRF, and effectively that's a recycling facility that will take in the trash. It's designed to accommodate up to 1,000 tons of trash per day and about 200 tons of recyclables. We use highly automated technology to sort through the waste. Technology comes from Europe, from the Netherlands, Germany, Austria, Spain, and Italy. And the equipment results in a very effective separation of the waste into 3 main streams. It recovers the valuable recyclables, glass, metal, paper, plastic, cardboard, wood. It recovers the valuable organic waste, which is food waste and other compostables, wet paper and cardboard. And then there's a small amount of residue, maybe 40% residue, which will continue to be landfilled. The organics then are transferred to our neighboring anaerobic digestion facility. This is a technology that comes from Germany, which is the world leader in anaerobic digestion. I think they have nearly 9,000 AD facilities in Germany, and I think in the US we're approaching about 300, with approximately 30 in California. So Europe is about 15 to 20 years ahead of us in terms of waste diversion, recycling, energy recovery through anaerobic digestion. But this was the kind of project that Santa Barbara was looking for. They're looking for the best available technology to achieve the maximum diversion, including the most resilient energy components. So let's dive into the energy components. The MRF includes two 1.4 megawatt combined heat and power CHP engines. The initial fuel for these engines will be landfill gas that is generated from the landfill where we're constructing the project. We have two separate Rule 21 SCE interconnections to the grid, one for the MRF, one for the anaerobic digester. The MRF is set up on a net energy metering tariff. Our goal for the 2.8 megawatts of cogen, combined with rooftop solar arrays of about 1 megawatt, is to meet 100% of our on-site load requirements for all of the sorting technology, as well as all of the parasitic uses of the anaerobic digestion plant. And we achieved that with our 2.8 CHP and the solar. Net energy metering, great program. If you're using a renewable fuel like landfill gas, we effectively get to be exempt from demand and standby charges, which can be significant, as you may appreciate. Our grid cost of power for this project was estimated between 14 and 15 cents per kilowatt hour, including the demand and the standby charges. And our cogen facility, including the landfill gas as a fuel, which is a reasonable cost for us, is about 5 to 6 cents per kilowatt hour. In the future, we may wind up upgrading that landfill gas for on-site fuel station and grid injection. They're very attractive credits. You may be familiar with the US EPA RIN credit program, and in California, the Low Carbon Fuel Standard program. In that scenario, if we were to purchase grid gas to fuel our on-site CHP engines, it would increase our cost about 8 cents per kilowatt hour. And if you got a 3 to 3.5 megawatt load for your plant, a significant annual cost advantage. And then our levelized cost in the 5 to 8 cent range included all of our costs of O&M and reserves for replacement and CapEx and financing costs. So tremendous economic advantage. They complete the energy project description over at the AD. The anaerobic digester will process about 35% of the waste that comes into the recycling facility. That's the estimated organic fraction. We load that up into 16 concrete tunnels. They accommodate about 450 tons of waste. So the AD is about 80,000 tons per year capacity out of our total waste processing of about 250,000 tons per year. Anaerobic digester, over a 28-day digestion cycle, produces the same amount of methane from our organic waste that would occur if we're buried in the landfill over a 15 to 16-year time horizon. So very efficient, controlled anaerobic digestion composting process. At the end of the 28 days, the material comes out of the boxes and we put it on a composting area. Eventually, we have to screen out some of the inert contaminant fraction, some of the film plastic and glass that comes through at the trash. But then we have a very viable agricultural quality compost that will be delivered to farm users, non-food crops in the Santa Barbara County area. The anaerobic digester, two 1.1 megawatt engines will burn the biogas. We have a 20-year fixed power purchase agreement with SoCal Edison pursuant to the biomat tariff set up exclusively for anaerobic digesters in California. It's great. It's fixed for 20 years. It's 12.7 cents per kilowatt hour, which is one of the highest tariffs available for renewable projects in California. Produce about $2.5 million a year in revenues, which is very helpful to cover the cost of our bond financing. In both of these applications, we have a beneficial use for the cogen heat. At the MRF, the cogen heat is used as part of our recycling process. We actually take the exhaust heat and run it through a paper dryer because our goal is to recover all the valuable recyclables from the trash. If the trash comes in from the residential homes, there's a significant amount of paper and wet cardboard. We put it through a paper dryer with our free heat provided by the CHP, and that increases the value of this recyclable commodity significantly. We also use the heat from the CHP to evaporate condensate that comes from the landfill gas, our primary fuel for the engines. And we also preheat a siloxane removal system with the heat as well. So a number of beneficial uses. Over at the anaerobic digester, we take the cogen heat to heat the digesters, the concrete tunnels where the organic waste is processed for 28 days, and that accelerates the AD process and stimulates the biogas production. So combined heat and power was the perfect solution for our waste processing technology, design, and energy production. In terms of resiliency, the focus of this call, our project is located at the landfill, which is about 20 miles to the west of the Santa Barbara community. This is a critical public works infrastructure project that happens to be located in a high wildfire risk area. We've been advised by SoCal Edison following the Thomas fire in Ventura County a couple of years back that we should anticipate 14 to 28 days per year where the Santa Barbara area may be grid disconnected with a public safety power shutdown event. This project must continue to operate 6 days a year, 2 shifts per day. So in the event of a grid disconnect event, our CHP engines disconnect from the grid and then are fired up on island mode, which allows us to continue generating power on site, behind the meter, without missing a beat. The anaerobic digester is normally delivering power to the grid pursuant to its power purchase agreement. In a grid disconnect scenario, we flip a breaker and its power will be used for on-site uses. So we achieve tremendous resiliency with the CHP. We're benefited by the landfill gas on site today, but we fully anticipate the landfill gas will diminish over time, at which time we have a SoCal gas pipe to the site, and we look forward to replacing our landfill gas with very reliable grid gas at some point in the future. Again, the summarized financials: significant cost advantage over grid provided power. The CHP achieves our resiliency goals perfectly at a very cost-effective solution, and is a critical part of our waste diversion renewable energy project, of which Santa Barbara County is extremely grateful for our participation. So I think, Jeff, that probably covered it. I know there's another slide. I forgot to say next slide, but it's pretty much the same concept here. There's a photo of our engines installed on site. Again, the benefits: lower electricity cost, avoiding demand, standby charges, clearly independence, mitigating future grid cost increases. Again, no outage, no downtime. The trash gets delivered 6 days a week. We must process it, otherwise it goes in the landfill, which doesn't achieve the environmental goals of the project. Reliability, resiliency. Could not say enough about our next speaker, Carlos Pavon from AB Energy. They're the supplier of a couple of our engines at the project. It's been a great relationship to work with these guys, and they have been very, very professional, Yeah, punctual, efficient. They meet every requirement the county put forth in terms of budget and schedule. And so with that, let's turn it over to Carlos.
John, thank you very much for that feedback and for the info shared on your project. That's much appreciated. This brief slide to tell the attendees a little bit more about how the economics of CHP projects work in general. Now, until let's say 3 to 2 years ago, CHP projects were driven mostly by economies related to electricity production using a low-cost fuel plus heat recovery. In other words, and you have a good example on your screen, think of a typical industrial project where a manufacturing facility in the food sector, beverage sector, pharma, requires electricity and thermal to be supplied for the production process. What happens is that usually the facility will buy electricity from the grid. They will buy fuel to supply on-site boilers and provide steam, hot water, or other thermal vectors for their manufacturing processes. Or they will, they will also have mechanical chillers, compression chillers on site to provide cooling demand for ambient or for process cooling. In this situation, our customers usually know how much they're paying for electricity and how much they're paying for fuel, and therefore they can calculate the total energy savings for the energy costs for the facility. What happens with cogeneration is that instead of covering your base load or the large majority of your load with the utility, you install a CHP at your facility, which consumes or burns low emission natural gas, low cost natural gas to produce electricity on site. Simply, the cost of producing your own electricity with that fuel is lower than what you would pay to the grid to have access to that electricity. In addition, the technology cogeneration, which can also be combined cooling, heating, and power, produces thermal vectors, which can be, again, steam, hot water, or also the direct exhaust of the system can be used in certain processes. Produces thermal vectors or also cooling in the form of chilled water with inclusion of an absorption chiller in the system. It's a through waste heat recovery from the unit. So when the unit generates electricity, it produces a certain amount of waste heat that needs to be otherwise dissipated. Instead, we recover it through certain systems that are included in the plant, heat exchangers, etc. And we make those available to be used at the facility. Thereby, we're reducing the fuel that the amount of fuel consumed to generate those thermal vectors, and also the amount of electricity that would otherwise be used to generate that electricity. If we put that additional benefit into the balance of the CHP project, then the financial benefit or the economic benefit of the project is further increased. In addition, there are also incentives that are available for cogeneration projects. May those be natural gas fueled or biogas fueled in California, as John was mentioning before. And this was the cogeneration market until, let's say, 3 to 2 years ago. What happened then is that in California and in other locations in the US and worldwide, utilities are facing challenges implementing renewable technologies in their portfolio, backing or helping those usually non-dispatchable renewable technologies with dispatchable low emission technologies as part of the mix. Therefore, utilities are facing an energy mix challenge, but also specifically in California, as we all know, facing other types of challenges in terms of wildfire, in terms of financial structure as well, the financial situation of PG&E, just to give an example. That has created for the last couple of years an additional driver for cogeneration projects, which is resiliency, and the main concept that we want to cover through this webinar. In addition, basically, to the economic savings that a cogen project can create, the cogen project also provides resiliency for the facility. We can identify, and that's, let's say, where the know-how of this team comes into play. We can have a look at your facility and understand, first of all, the economics, to understand the usual business model for a specific CHP project, and then understand the structure on the technical side, the structure of your facility, to understand which critical loads need to be served continuously, even when the grid is not there. We can set up a modification of your existing single line diagram to serve those loads through the future CHP facility, and thereby understand the additional value that the system can have for your specific operation. So going into the specific example that you see on the screen, for this specific customer, we had determined that the annual savings for energy were in the range of $500,000 per year, basically, by producing your own electricity on site instead of buying it from the grid. The customer was saving more or less $500,000 per year. In addition, due to the islanding capability of the system in provide resiliency when the grid was not there, the customer was avoiding estimated costs of additional $120,000 per year, for a total benefit of $650,000 per year. So the main concept that I would like to share is how the cogeneration market has shifted from a purely economic driven market into a resiliency driven market, where the added value of the units, not only economic savings, but also resiliency against outages. I think I would cover those main points through this slide, and I would give the word back to Jeff, and then I'm available for any questions that you may have. Jeff?
Thank you, Carlos. Conscious of the fact that we're coming up at the top of the hour here, so we'll now turn it over to Libby Edgar to talk about business and financial models for delivering energy resiliency solutions.
Thanks,
Libby?
Jeff. And thankfully, I actually talk pretty fast, so hopefully I can make up some time for us. As Jeff mentioned earlier, there are two basic financial models that we employ with distributed energy projects. The main difference between them is who owns the asset and where it shows up on the applicable financial statements for the parties involved. The first structure that you see on the left here is what is considered to be the traditional one. The customer hires GIE to design and install the project on their behalf. The customer provides the upfront priorities, the data needed for GIE to perform the energy savings analysis, and the conceptual technical solution option identification. Then the customer works directly with the GIE technical team to ensure that the requirements are met, and finally the customer provides the required capital to fund the project. GIE puts together the budgets and the schedule, usually as a fixed price turnkey, which incorporates a standard work in progress payment schedule utilizing stage gate approach for acceptance of project progress. It can also be time and materials if that's what needs to be done. Once startup and commissioning is complete, which includes the performance testing to ensure that the project meets the agreed output levels, then GIE construction team hands it over to either GIE operations, the customer, or another counterparty for ongoing operations and maintenance. As part of this model, GIE can refer the customer to the Shell affiliates for natural gas, grid power if they're a direct access customer, and then renewable energy credits at competitive pricing. However, do keep in mind that Shell will contract directly with the customer for whatever is supplied by Shell, and is contracted directly with Shell. It's highly encouraged, of course, that customers contract with GIE for the long-term operations and maintenance as we have designed and installed the project. So it also includes some additional performance and reporting guarantees that help ensure that the customer is getting the most out of the project in the operations life of the asset. The second option is called energy as a service, the one on the right. It may be a new concept for many. The core concept of this model is to transfer the risk of owning and operating an energy project to a third party that is in the business of energy, thus allowing the customer to focus on their core business. We accomplish this by having the customer provide the same upfront priorities and data. We do the same analysis to figure out the energy savings and then the configuration for the project. GIE designs the project in the same basic way, then goes to Shell or an energy investment market to secure the capital financing for the project. By securing the energy, or by structuring the energy and thermal output of the project in an energy as a service contract, the customer can treat the expense just like a utility bill. There are a few minor changes in the construction of the project under the energy as a service model. The main one being a site access agreement between the customer and the project financer for the space necessary to house the project. Because the project is installed at the customer facility, under the requirements initially set up for the site, the customer gets all the benefits of resiliency, reliability, and energy savings passed directly through to them. Embedded in the financial model is the natural gas requirement to run the project under baseload conditions. If the customer, again, is a direct access customer, like in the design build model, then grid power can also be available through the affiliate relationship with Shell. GIE can also, or does also include in the full scope of the natural gas project output, backup power and RECs as included in the energy as a service agreement to make it what's called or considered a full requirements 365 agreement. With the energy as a service model, the financer and the customer get the benefit of GIE designing, building, operating, and maintaining the project for the life of the contract or for the life of the asset, depending on which is longer. The same great performance and reporting guarantees are included. The key to keep in mind with both financial models is that GIE works directly with the customers and with our partners to customize the right solution. And it is a group effort with our trusted partners, like I said, AB Group, Shell, and others, to ensure that the solution designed and installed will be the right solution for each customer's unique needs. Jeff, I'm going to hand it back to you now, let you talk through the high-level process to kick off a new project, but I look forward to working with folks on the phone to get their projects off the ground.
Thanks, Libby. We're running out of time quick, and I do want to make sure that we can address questions from the audience, but I'll just say a few quick words about the planning process and related to the development of resiliency solutions. It really starts with your organization, your business, to determine risk and priorities. And that's an internal discussion in trying to establish boundary conditions for energy savings and resiliency. The risk posed by PSPS events, the 2019 season probably won't look like the 2020 season, and so on and so forth. Are you looking for a 100% solution, just emergency situations? Is your view that you'll have a short or long-term PSPS event to contend with? What are the impacts to your business if you don't do anything? One of the more important discussions is what are your priority electric loads, and can you entertain a load shedding program, or do you need to have full requirements during a PSPS event? And of course, it all comes down to risk and how you identify risk, measure it, and estimate the cost associated with being offline due to a PSPS event. So, the good news is you have most of the information at your fingertips already. You have your utility bills. You can request your electric load data from your load serving entity, and you can begin that planning and project framing process to the extent that resiliency is viewed as a critical hedge against outages and increasing utility costs, which was obviously a big consideration for John Dewey with his project in Santa Barbara. And then from there, you can begin to frame and design the correct solutions and the financial model for implementing the project based on capital budgeting requirements, risk assessment, and and other considerations that will be important to you and the decision makers in your organization. So with that, I'd like to hand it back over to John Passmore, and see if we have a couple questions. I believe we have this line open until a quarter after, so you have availability. Please, we encourage our audience members to stay on if you have the availability.
Great. Well, thanks very much, Jeff, and also the same to John and to Carlos and to Libby for a very interesting presentation. As you mentioned, we're running a little short on time, but we do have some questions here which I'd like to toss out to the group. Perhaps one for Libby to start with. Got a question here. What is the cost of having a GIE financier fund the capital? Obviously, cost of capital, a very interesting topic here.
Yeah, well, the easy answer on that one is it depends. But on average, the cost of capital, and depending on the different incentive programs that we're able to take advantage of, the cost of capital is usually anywhere between 5 and 9%. So it's very competitive to bonding markets options that folks have, and then to any debt financing, project financing if it's embedded in a structured financing project scenario.
Okay, thank you. I've got another question here from Alexander. Last year, the FREC issues Order 841 allowing battery storage to participate in wholesale energy markets, and talks of allowing all distributed energy resources to participate in wholesale markets. Would allowing DERs to participate in wholesale markets and provide grid services benefit the economics? Could this also reduce PSPS events? Is there anybody who would like to take that?
Yeah, this is Libby. I'll take that one again, and I'll pass it off to anybody else that wants to answer. Absolutely, any and all assets and any and all different types of assets that can be made available to the merchant markets are going to make them more cost competitive. One of the difficulties that we have seen in the deregulated markets is that the rules have not been set up and established for the distributed energy resources, specifically batteries, to participate in the merchant markets as efficiently as just what I'll consider just a kind of a utility scale asset. So we're seeing like as you mentioned, the FERC, and we're seeing the different ISOs evolve their market rules, and the way that the distributed assets are being connected to the grid. We're starting to see some of that happen, and we're starting to see the same benefits of that. But exactly to your point, a lot of these distributed energy resources, especially batteries, have the ability to be load or supply. They can provide energy or ancillary services for grid support as well. So, and they can do it on longer term and shorter term with almost instantaneous startup. So from a grid reliability perspective, distributed energy resources are very beneficial to the merchant markets.
I would just,
yeah, go ahead.
Yeah, I would just tag on to that, Libby, where we're seeing it operationalized with a higher level of clarity is with a number of the CCAs in the state, which do put a value on resource adequacy for distributed energy resources. So we're engaged in several discussions around specific projects in Northern California with CCAs there. That have resource adequacy plans and will pay for RA value in projects depending what the location is on on the grid, and the nature of the asset, whether it's battery, solar, CHP. So we think that's an encouraging development as well that can add to the overall value or revenue stack of a project.
Great, okay, thank you. Actually, kind of a related question here. To do with diesel, actually, it seems we've been aware of this in the work that we do out in the field, that there are obviously quite a lot of existing diesel generator sets out there. And the question is, aren't backup diesel generators a lower cost solution than CHP, solar or battery storage? Could I don't know who'd like to answer that, but could you put that in the context? Because it's obviously not just cost, but it's also the cost of using something which tends to be a bit of a nasty polluter.
Yeah, this is Jeff. I'll try to provide a quick answer to that. Yes, standby diesel generators, very much a proven technology. Comparatively lower cost, first cost in relation to the distributed energy resources we described today. But that being said, there are challenges with diesel generators, not the least of which, emissions here in California, but also just resiliency of fuel supply to those generators. If you're riding through on a 4, 5, 6 day PSPS event, will you be able to maintain delivery of diesel fuel to the facility, and what happens if you don't? I don't know, Carlos, I know you've chatted with me about this before. I'm not sure if you have anything to add.
Yes, gladly. In fact, diesel generators as an alternative to cogen usually comes up when the driver for the project is resiliency. As I had mentioned, the driver for a cogen project should not only be resiliency. In fact, the economic saving is there, which is not there in case of a diesel engine. Also, actually, more than a couple of our projects have been resiliency projects have been driven precisely because the diesel gensets that were on site. I'm thinking of a specific customer of ours in Southern California. They had 4 megawatts of diesel generators bought specifically to work against PSPS events. When the events happened, it was the hottest day of the year. The diesels didn't start, and the customer lost its production for multi-million-dollar value. So diesels do not offer the same advantages that a cogeneration system offers at all, specifically when we're talking about events that last more than a couple of hours. That would be my feedback on that question.
Great. Okay. Thanks very much, Carlos and Jeff. Here's another one on the topic of pollution. The question is: I've heard of challenges when it comes to air permitting of CHP units using recips. Can you comment on that?
I think I will jump in there, Carlos Pon again here. In essence, California is divided in more than 30 air pollution control districts. Each of these districts have different emission limits that apply for cogen units of a specific size. The worst case scenario, I think, will be South Coast Air Quality Management District, which covers part of Southern California, a good chunk of Southern California. I would say, for what regards to this technology, internal combustion engines, lean burn, with an SCR treatment system, we are able to comply with the lowest limit applicable in California, which is 0.07 pounds per megawatt hour. In addition, and that is the worst case scenario that I was mentioning for South Coast Air Quality Management District. In addition, when the customer recovers heat, those megawatt hours in the denominator of the emission limit can include thermal generation, effectively increasing the applicable emission limit for that specific plant. So unless we're talking about very specific projects, very large projects, 5 megawatts and above, 10 megawatts and above, in air quality non-attainment areas, which could require a specific permit. If we're talking about standard permits, standard projects, there's absolutely no issue in respecting emissions on island operation, on grid parallel operation from 50% to 100% of the load. It's no question.
Okay, thanks, Carlos. Appreciate that. Here's another one. Obviously, it's always very interesting to know what the response of the utilities are to developments within the energy sphere, particularly when it comes to microgrids, DER, etc. I have a question here. PG&E has announced that it will be setting up mobile generators at substations. Will this address the PSPS problem? And I guess a further question would be, how does that affect the issues that we're talking about generally? Who'd like to take it?
Yeah, this is Jeff. I think I'll try to address that. So, PG&E has announced, the deployment of what they're calling temporary microgrids in certain areas in Northern California. I believe this could impact some 60-odd substations. And they're in areas, as you would imagine, were disproportionately impacted by fires and PSPS events. Counties like Shasta, El Dorado, Napa. And I believe the way this is going to be set up is that the temporary microgrids will generate and supply power to critical and essential facilities only. So naturally that would include operations like hospitals, fire stations, gas stations, supermarkets, pharmacies, to make sure that essential and critical facilities for residents can keep the lights on. I don't believe, at least in the the formulation of the program that is out there at the moment, that this will directly benefit commercial and industrial and other institutional customers. So I think it's a piecemeal approach, part of the bridge that PG&E is trying to build over the next 10 years to harden their grid.
And just a question from me following on that, Jeff, does that suggest that this is another layer of expense that PG&E will be building into its ultimate demand from ratepayers? Right?
Absolutely, John. This is obviously a reactionary response, with pressure from the Public Utility Commission, and I'm sure in no small measure has been baked into the requested rate increases that are sitting before the Public Utility Commission right now.
Right, got it. Okay, good. Thanks so much. I've got one more question here on the finance side, Libby. Perhaps you could take this. Does GI Energy guarantee off-balance sheet accounting, or the ability to do off-balance sheet accounting?
So GIE is not in the business of doing financial advising. So we do structure each of the energy as a service agreements or the financial model. We structure it so that the contract eliminates the triggers for the customer that to be considered lease accounting treatment. So the way that we structure the contract normally will pass all those triggers, or we won't actually impact those triggers. Again, GIE, we are not in a financial consulting business, so we definitely rely on customers, financial advisors, and auditors to make that determination for them. And we have flexibility in the way that we structure the contracts to ensure that it does meet those needs.
Okay. Well, I think that kind of brings us to the end here. I don't see any new questions coming in, and we've gone obviously 10 minutes over, so we do thank everybody for their time. I'd like to wrap this up now. Would anyone have any last-minute statement they'd like to make on our topic? I guess that silence tells a story. So what I'll do, I'll just say thank you very much to John Dewey from Mustang Renewable Power Ventures, to Carlos Babon from AB, and my two colleagues at GI Energy, Jeff Bogg and Libby, our CFO, Libby Edgar. Thanks very much, everybody, for attending this today. And if you have any questions and want to send us any comments about what you heard today, or have further questions that may occur to you after this event, on the chat line on the Zoom program, you'll see that there is actually an email address of our colleague Retta Maynard, who you can send questions to. But thanks again. We appreciate your attendance today, and we wish you luck and look forward to speaking to you all in the future. Thank you very much.